In this video, we're going to take a more scientific look at acids and bases. And we're going to start with the Arrhenius definition of acids and bases. So first for acid. An acid is any compound that produces a hydrogen ion in solution. And it's a little actually not true to call it a hydrogen ion, because what happens is as soon as that hydrogen ion is in water, it will associate with H2O to form positively charged hydronium, H3O+. And we can see that here for HCl. When HCl is put into a solution, you get H plus and CHL minus, and that H plus will form H3O plus. However, for chemists, we usually just write H plus as shorthand. For a base, an Arrhenius base is anything that produces OH minus, or it's also called hydroxide. So if you look at the base sodium hydroxide, it'll form to make sodium and hydroxide. However, this hydroxide does not react with anything else. It just stays as hydroxide. And when you make an acid and a base together in solution, what you get is salt water. So hydrochloric acid plus sodium hydroxide will form sodium chloride in water. So that's Arrhenius acids and bases. We also have a different type of acid and base. That's called the Bronsted-Lowry acid and base. And for acids, they're actually the same as the Arrhenius. They both will donate or produce H plus in solution. The only real difference, though, is when it comes to the bases. So for a Bronsted-Lowry base, the hydrogen is the acceptor. So here, HA is an acid, B is the base. This acid will donate this H, this B will accept it. See, as if we go back to Arrhenius, here it's just OH minus in solution. Bronsted-Lowry says, no, you actually accept a hydrogen. Okay? And we can take a look at this type of reaction. So HCl plus water. So we said in the Arrhenius definition that the hydrogen will actually go and make H3O plus. Well, in the Bronsted-Lowry definition, the same reaction's happening. We're making H3O plus, but we have something accepting that hydrogen. That would be H2O. So here in the Bronsted-Lowry definition, HCl is our acid. H2O is actually our base. Now let's look at NH3 and H2O. Here we have H2O giving a hydrogen to NH3. So H2O, water here, is an acid. NH3 will accept that hydrogen, and so it's the base, and that'll go to form NH4 plus OH minus. All right. And so, as we just saw there, water is something that can act either as an acid or a base. And those types of substances are amphoteric substance. Amphoteric substance just means something that is an acid and a base. Has an acidic hydrogen, but can also take on a hydrogen. And to do that, you need an atom with a lone pair of electrons. So as I said, water is both an acid and a base depending what it's mixed with. All right. So the good thing about looking at acid and base reactions through Bronsted-Lowry is that these reactions are reversible. For example, we have our acid and our base, and here on our product side, what we can do is just reverse this reaction, and now our former base is our new acid, and our former acid is our new base, and we can just do this over and over again. All right. So the original base will have that hydrogen, and it will act as an acid in the reverse process. And the original acid, A, will now have a lone pair of electrons, so it will act as the base. And by thinking about acids and bases in this manner, we get what are called conjugate pairs. All right. So let's look at this reaction. We have NH3, which is our base, so it's accepting a hydrogen according to Bronsted-Lowry. H2O is our acid. So when the acid donates a hydrogen, it becomes a base. So we can pair up this H2O, this acid, and this OH minus, its base, and this is called a conjugate acid-base pair. So the acid and its conjugate base, that is how we talk about this terminology. While the base gets a hydrogen, and it can be an acid in the reverse reaction. So this is its base and its conjugate acid, its conjugate pair. So when talking about conjugate pairs, the only difference between conjugate pairs is that there's a difference of one hydrogen. And the acid is always going to be the substance with that extra hydrogen. So NH3 is the base, NH4 is the conjugate acid. H2O is the acid, OH minus the conjugate base. All right. And generally, how we name these things is what is on the reactant side is just the base and the acid, and what's on the product side, that's when we add the word conjugate for conjugate acid and conjugate base. All right, that's it for this video. I'll see you in the next video.